Have you ever wished you could just, read an examiner's mind? Well, in this explainer, we're going to do the next best thing. We are cracking open a real AQA GCSE Physics exam question to show you not just what the right answers are, but why they get the marks. It's all about learning to think like an examiner to really boost your score.
Okay, so here's the game plan. We're going to break this question down into its three main parts: star stability, the end of a star's life, and then a bit on galaxy speed and light. And then we'll wrap it all up by decoding the mark scheme itself to find those golden nuggets of information that'll help you ace your exam. All right, first up, let's tackle a huge question in astrophysics. Why doesn't a star just collapse? We're diving right into question 03.1, which really gets to the heart of what keeps a main sequence star, like our very own sun, perfectly stable for billions of years. And for this, we are going straight to the source. This is the official AQA question paper and its mark scheme from June 2021. No guesswork, no, I think this is right. This is the real deal, exactly what the examiners are working with. So here it is, the first part of the question. It's a 2-marker, and it asks you to explain why the star is stable. Now, that word explain is super important. It means you can't just state a fact. You got to give the reasons why. This is where we get into real exam technique, isn't it? Knowing the physics is one thing, but you have to serve it up in just the right way to tick the examiner's boxes. So what does a perfect 2-mark answer actually look like? And here's where it gets really interesting. Check out how these marks are given out. You get your first mark for identifying the two forces playing tug of war: gravity pulling everything inwards and the immense forces from fusion pushing outwards. But, and this is the crucial bit, you only get the second mark for saying they're in equilibrium or balanced if you've already got that first point. You see? The marks depend on each other. Just writing the forces are balanced gets you nothing. Precision is everything. Okay, so now that we get what keeps a star stable, let's look at what happens when that balance is lost. The next part of the question is all about the future, the final stages for a star about the same size as our sun. Right, this one is worth 3 marks, and the key command word this time is describe. When you see that, it's a huge clue that they're looking for a sequence of events, a story. You need to lay out what happens step by step. 3 stages, 3 marks. It sounds simple enough, doesn't it? But there's a sneaky little detail hidden in the mark scheme that catches so many people out. It's an easy place to drop marks if you're not careful. And here they are, the 3 steps the examiners want to see, in exactly this order. First, the star swells up and becomes a red giant. Then it throws off its outer layers and collapses into a tiny, dense white dwarf. And finally, over an unimaginable amount of time, it cools down and fades into a black dwarf. And this right here is the crucial point, taken word for word from the mark scheme. The sequence is non-negotiable. If you get the order wrong, say you put white dwarf before red giant, you cannot get all 3 marks. Even if you name all the right stages, the order is what matters. Sequence is king on this question. All right, let's move on to the last part of this question. We're going to switch gears now from pure theory to interpreting data from a graph. This is a classic physics skill, and they love to test it. So we've got this graph that plots how fast galaxies are moving away from us against how far away they are. The question asks which one shows the smallest change in wavelength. Now that's just a fancy way of talking about redshift. Basically, the faster a galaxy is moving away, the more its light gets stretched out to longer, redder wavelengths. Our job is to pick a galaxy and say why we picked it.
And the mark scheme is crystal clear on this one. Your first mark is purely for identifying galaxy A. That's it. If you pick B, C, or D, you unfortunately can't get any marks for this part of the question, even if your reasoning is good. So what about that second mark? Well, to get that, you need to give a valid reason. And here's a little inside tip. The mark scheme actually gives you 2 correct options. You could say it's because galaxy A is moving the slowest, or you could say it's because it's the closest to Earth. Either of those reasons works, because they're both correct interpretations of the graph. But remember, the reason only gets you a mark if you chose A in the first place. Okay, let's zoom out and pull all of this together. We've just dissected 3 parts of one big question. So what have we really learned about how to approach these questions to get every single mark you deserve? This table really lays it all out, doesn't it? For the first part, the big lesson was about dependent marks. 1 point unlocks the next.
For the second part, it was all about sequence, sequence, sequence. And for the third part, we saw that you have to get the first bit right to even have a chance at the second. But also that sometimes there's more than one right way to explain your answer. It's not just about knowing your physics. It's about understanding the logic of how you're being marked. So there you have it, a deep dive into question 3. And if there's one thing to take away from all this, it's that knowing the content is only half the battle. You also have to understand the rules of the game, how the mark scheme actually works. It's all about thinking like an examiner. So, let me ask you, the next time you sit down with an exam paper, how will you change the way you answer the questions?